welcome to my YouTube channel. Hope you all are doing good. So today we will discuss halogenation of alkanes and we will focus on chlorination. So chlorination of alkanes. So chlorination of alkanes involve three steps: chain initiation step, chain propagating step, and chain terminating step. Now we will discuss about these steps in details. So what happens in chain initiation step? So this is the first step and it involves the homolytic dissociation of chlorine molecule into the chlorine atoms or free radicals. Now, if you don't know the free radicals, I will pin that video. Do watch it. Okay. So the initiation step is, so this is the initiation step. What happens? The very first step is, okay, let me take another color. So the very first step is chain initiation. So what happens? Chlorine molecule undergoes homolytic cleavage. So we have a chlorine molecule and it undergoes homolytic cleavage in the presence of light or at high temperatures like 773 Kelvin. And it forms chlorine radical. How to show that? Take a chlorine molecule, show the homolytic cleavage. So this is the homolytic cleavage shown by half-headed arrows. So this is the chain initiation step. The next step we have is chain propagating step. So what happens here is free radical that is formed in step 1 will attack the molecule of methane molecule. So, okay, before that, what is the reaction? The reaction is CH4 plus Cl2 give rise to CHCl, CH3Cl plus HCl. So this is the whole reaction. So we have to make this molecule. Okay. So the second step we have is chain propagation step. Let me write here. Chain propagation step. So methane, we will take methane molecule. And next we have chlorine radical. The chlorine radical formed in first step will react with the methane molecule. How it will react? So basically now this bond, so what will happen? It will, this chlorine radical will react with this H and this bond will undergo the cleavage, forming this radical plus HCl. So this is my methyl radical. So there could be another step. For example, this methyl radical can further react with chlorine molecule like this. So this methyl radical formed can react with Cl2 molecule. So what will happen? This will give rise to chlorine radicals. So one chlorine radical will react with this, will combine with this methyl radical to form Cl plus H plus Cl radical. So they are chain propagation steps. Okay. Now the last step we have is chain terminating step. Chain termination means the end step. So there can be many. So what are the chain termination steps basically? So these are the reactions which remove the reactive species, that is our free radical needed for the propagation. Okay, here the free radicals will be removed. So in what, so can you see here? Here we have a free radical. So this, let me take this free radical. So this free radical can combine with, so I will represent it like this. So this can combine with another radical of same type and can form C2H6, which is my ethane. This could be the first possibility. Another possibility, we have a chlorine radical. So these chlorine radical will combine with another chlorine radical to form Cl2. So this can be a second possibility. And third possibility, so we have a methyl radical and a chlorine radical. They both can combine together. So what will happen? CH3 radical plus Cl2 radical, Cl radical, sorry, Cl radical, it can combine to form CH3Cl. Fine. So these are the major steps. So chain initiation step, chain propagation step, and chain termination step. I hope this is clear. So next, what we will do, we will discuss some questions. Then the concept would be more clear. Okay, let us proceed to the questions. Do write them on your notebook. So I'll repeat it. First of all, in the chain initiation step, two Cl molecules, we have a Cl molecule. It will undergo homolytic cleavage to form two Cl radicals. Now this Cl radical will combine with methane molecule to form methyl radical and HCl. So methyl radical can combine with another chlorine radical or chlorine molecule to form chloromethane and plus chlorine radical. Then there will be chain termination steps where the free radicals will be consumed. Okay, I hope this is clear. Now let us move to the questions. Okay, so we have the first question. It says that a refrigerant used in air conditioner is a mixture of fluorinated alkanes. These compounds are made by fluorination reaction. Okay, so write the overall reaction for equation for the reaction of fluorine with methane to form trifluoromethane. Okay, so we have to write a reaction. So what we need to take? We need to take methane. Now what is methane? CH4 plus reaction with fluorine. Fluorine is a diatomic. F2 to form CHF3 plus there will be formation of HF. So now balance this. This is an unbalanced equation. So 3 here and a 3 here. I hope this is balanced now. Okay, the second says write the equation of the steps of the reaction of the fluorine with trifluoromethane to form tetrafluoromethane. Okay, so we have to show the formation of tetrafluoromethane. So first is initiation. Just remember, in initiation, what happens? Always there is a radical formation. So the first step would be F2 will undergo in the presence of light or any other thing. So I will write H nu in the, it forms two fluorine radicals. Or you can show it like this also. So like this, fluorine radical plus fluorine radical. So this is the first step. Second, they are saying first propagating step. So basically now we have trifluoromethane. So I will take trifluoromethane. Trifluoromethane, it will react with fluorine radical. So what will happen? This bond will cleave like this. So we will have this plus HF. So second propagation step. Now how to show this formation? Basically, I guess you know this. Now we have second propagation step. So what we have to show? We have to show the formation of tetrafluoromethane. So this is my trifluoromethyl radical. So this is my free radical. Now what will happen? So this free radical will combine with F2 to form this plus F radical. So this is the formation of tetrafluoromethane. Just remember what will happen here. You have a fluorine. It will undergo again dissociation. And it will, this two radicals, here we have two radicals will be formed, which we will have this radical plus FF like this. From here we get F radical plus F radical. So one F radical will combine with another fluoromethyl radical to form tetrafluoromethane. I hope this is clear. Now, next they are saying a termination step leading to formation of hexafluoroethane. So first of all, you should know the structure of hexafluoromethane. What is the structure of hexafluoromethane? Hexa means 6 fluorine and ethane means 2 carbons. So 2 carbons and 6 fluorines, like this. Okay, so we have to make this compound. Okay, so just remember, we have to show the termination step. Okay, okay, I'll just take this. So what we have? So we have this radical, correct? This radical is present, so I will take this radical. So this radical can combine with another molecule of this radical and they can form CC, FFF, FFF. Fine. So just remember, in the propagation steps, you will get radicals. And in the termination step, you won't get the radicals in the end product. And initiation is always the homolytic cleavage. Initiation would be, just remember one thing, initiation would be homolytic cleavage. Propagation means you will get radicals on the product side. You will get free radicals on product side. And termination means no radical. All radicals consumed. Termination means radicals consumed. Okay, I hope this is clear. Okay, now let us move to the second question. So which molecule is not produced when ethane reacts with bromine in presence of ultraviolet light? Now, first thing you need to pay attention is they are talking about ultraviolet radiations. So ultraviolet radiation means they are free radical reaction. So there will be a free radical reaction because in the presence of light, which is represented as H nu or UV, the free radical reactions take place. So let us write the reaction of ethane. Ethane is CH3 reacts with bromine, Br2. So what would be the product? Expected product would be, what do you think? The expected product could be C2H4Br2 plus HBr, 2HBr. So this can be formed. Next, HBr. HBr is formed. Now, what will be the reaction mechanism? Like, what would be the mechanism for this reaction if you see? So, the very first step would be again initiation. Initiation means homolytic cleavage. So, 2 bromine radicals would be formed. Second step, we will take a ethane molecule and ethane molecule will react with bromine radical to form this molecule, this basically ethyl radical. So ethyl radical plus HBr. So this ethyl radical is formed. Now there will be many ethyl radicals in the reaction. It's not like that there will be only one ethyl radical. There will be many ethyl radicals. So what can happen? So this ethyl radical can combine among themselves like this plus one more molecule. So they can combine together. So this bond and this bond, they combine together. What would be formed? Like this. So HH, HHCH3. Correct? This would be formed. What is this? C4H10, butane. So there will be formation of butane also. So this can be also be obtained. So they are asking which is not produced. So H2 is not produced. So the correct answer is H2. Fine. Hope this is correct. So option C is our correct thing. Okay. Now let us see the next question. So what they are saying, in the presence of ultraviolet light, methane and chlorine react to form a number of chlorine-containing products, including this and this. Write the equation for initiation step in the mechanism for this reaction. So basically, we have dichloromethane and trichloromethane. So we need to show their formation. So what is the initiation step? As I told you, initiation is always homolytic cleavage. So we will show the homolytic cleavage first. So they are asking about chlorination. So Cl2 will react to form two chlorine radicals, or you can show this way. Chlorine radical plus chlorine radical. So they are formed. Okay. Now they are asking about write the overall equation for the formation of this from this and this. Okay. So CH2Cl plus Cl2 to form plus HCl would be there. Now check whether the equation is balanced or not. Pause the video and check. I think it is already a balanced equation. So next they are asking write the equation for the two propagation steps by which this is converted to this. So dichloromethane is converted to trichloromethane. Okay. So we have to, so they are asking for the propagation steps. So initiation step we already started. So this is our initiation step. Correct? So let us write the propagation step now. So what will happen? So which we have this as a reactant. I will take this molecule HHCl. So plus there will be a chlorine radical, correct? They will combine together to give you this radical plus HCl. So this could be the step first. So we have to name, we have to tell them in two equations. The first reaction would be this. So the second reaction would be, so taking this as a radical, this radical will react with Cl2 to form Cl plus Cl radical. Again, see, here we have radicals. So they both are propagation steps. As I told you earlier also, propagation means you will get radicals on the product side. So this would be the second step. And here we have trichloromethane as our end product. Okay, hope this is clear. Just remember, initiation means homolytic cleavage. And then you have propagation. Propagation means you need to use the radicals. The radicals would be on the reactant side as well as on the product side. And termination means no radical on the product side. Okay, now let us move to the last question. So which of the following is least likely to occur in the reaction between methane and chlorine? Okay, so this reaction can occur. This is a propagation step, correct? So we have studied this. So this can occur. Even this is a propagation step. And even this is a propagation step. Now, if you look at this one, so what is happening here? See, here basically you have CH3 plus HCl. So it is giving you CH3Cl plus H radical, correct? So this is something weird. Why weird? So basically what they are saying, this bond is undergoing homolytic cleavage to give you CH3 plus H radical plus Cl radical, and Cl and this are combining together to form CH3Cl plus H radical. But if you remember, this is a heteroatomic species. And heteroatomic, they don't undergo homolytic cleavage. They just undergo heterolytic cleavage. Actually, the cleavage of this would lead to the formation of Cl negative, Cl negative plus H positive, carbon ion and carbocation. If you want to know more about homolytic and heterolytic, do watch my video. Okay, hope this is correct. This is clear. So option B is correct. So this is a least likely event to occur in the formation of chlorination of methane. So next, I have a question for you. Do try that question. So question says that explain the formation of CHCl3 from CH4 in presence of chlorine, Cl2, and solve this question and send it to the given mail, and we will check it and revert back. And just remember one thing, we also provide one-to-one tuition classes. If you need any in chemistry related to any topic, just send us a mail, we will revert back. Hope you enjoyed the video. If you like it, share it and subscribe it. Okay, bye-bye. See you. Bye, take care.